Okay, so last time we went over the first part of chapter 2. We covered what is a data warehouse, and we also went over the different parts that make it up. And today we're going to start with data warehouse development. When developing a data warehouse, you have two approaches you can take. You have more choices than that, but these are two of the most used approaches. The InMon model is basically a top-down approach, meaning they start with the database design or the data warehouse design, and then they build the data warehouse. The Kimball model is where you start with the parts and build up to the data warehouse. The Kimball model is a little cheaper because you don't have to build the whole data warehouse. But no strategy is better than the other. It depends on your needs. If you're a company that maybe you're starting with smaller areas, maybe you only need a few data marts to start, and you don't want to put out the money for a big data warehouse, you're going to use the Kimball model if you want to do a data warehouse later on. Whereas if you're a larger organization, you might want to start with the InMon model. And then there's always the hybrid approach between the two. The alternative is a hosted warehouse. That's where someone else builds your data warehouse for you. And there's always potential security issues with that because someone else is managing your data. But if something happens to where the data is accessed illegally or hacked, then they're responsible. They're the ones who have to deal with all the litigation. You can put the responsibility on them. Okay, representation of data in the data warehouse. The data warehouse use dimensional modeling. That means they go beyond just normal tables. You don't just have rows and columns. You have where you can pull from multiple tables at one time. And that's where the dimensional modeling comes in. They'll show you like a cube when they try to explain it, to where you have each side of the cube as different parts. But if you want to think about it in another way, you can think about one query being able to instantaneously access multiple tables. Basically because we're going to do a star schema in assignment 3, and you'll kind of see it. What it is the table, instead of the database having to access 5 tables to get the information, you're making one table that has all the information you need from those 5. So now you've broken down all these tables into one that it's going to access. And it's not confined because you're not going to have a primary key in that table. You're just going to have the data. So there's less confinement to it, and the database can access much bigger pockets of information. The star schema is the simplest form. It's basically a fact table surrounded by dimensional tables. So basically it's a table made up of parts from the tables around it. And then the fact table contains descriptive attributes, which are basically the attributes you want in order to perform analysis. Basically the most important data. Dimensional tables contain classification and aggregation information. So they're going to contain more information than your fact tables are. Another schema is a snowflake schema. It's kind of an extension of the star schema. It's a much bigger version of the star schema. It's where instead of just one table connecting to many tables, it's one table connecting to tables connecting to other tables. So here's some examples. This is the star schema you're going to make in your assignment. See, it's pretty simple. Just know that this table in the middle shouldn't have any primary keys because it's made up of parts from the other tables, including its own parts. So you'll have parts from here and then some of its own pieces. Okay, snowflake schema. It has that fact table again, but look at all these other tables. So instead of just having the one table, you have a table, but it's also pulling in data from other tables, and so on. So it's a much bigger version of the star schema. Okay. So data in the warehouse, in the data warehouse, is analyzed using online analytical processing. So remember, OLTP is the gathering and storing of your data for analysis. OLAP, online analytical processing, is the analysis of that data. So you basically have a data warehouse that's pulling data in from multiple places, formatting it to be uniform, and then it's going into the data warehouse. So if something is transforming it, then it goes to the data warehouse. And then you have data marts that are created, and those are accessed by middleware. So when you did Teradata, that's a middleware. It's going to access the data warehouse. So again, remember I mentioned the cube? That's where they try to show you how those tables are accessed in a different way. So OLAP activities, you can do queries, ad hoc reports, statistical analysis, and you can actually do multimedia-based application development. Okay, and here's OLAP versus OLTP. Remember, that's day-to-day business activities. This is decision making. You have transactional databases here. You have data warehouses under OLAP. This is routine. This is going to be more reporting. Resources are a regular relational database like you did in probably one of the MISY courses. You probably did a relational database in your Access project. And then these are going to be larger, more specialized databases. Now, OLTP is faster because you just have basic information. This is getting better as software is improving, as the way databases are accessed are improving. This is getting better. They have something, if you want to look it up, called in-memory processing. That's what the iPad uses, what the iPhone uses. It allows processing of information directly in memory, so you don't have to have a hard drive. You don't have to have a big hard drive. You can have a small one. So that's how you have these iPads with 16 gigs, and they run very well. In-memory processing, I might do a little project on that later on. Okay, so there's some OLAP operations. They're just basically ways of pulling data from the system. This might seem a little confusing because it's, again, that dimensional modeling they try to show you with the cubes. But basically, you're pulling out information you want. So you have a big database, you're pulling out pieces of what you want to know. So just to understand, that's what most of that is. Used to change the dimensional orientation. Yeah, so most of that is, it just involves pulling information from your data based on what information you want to know. Sales volume of a specific product based on time and region. Sales volumes based on a specific region, based on time and products. So see, you're specifying the data you want in the report you pull. It's a very technical way of explaining it here, but that's the gist of it. There's some variations of online analytical processing. There's multidimensional and there's relational. Multidimensional is an alternative to relational. The problem with it is it requires pre-computation and storage. OLAP doesn't require any pre-computation. It's going to generate, it's going to have a tool that accesses the database and generates SQL queries. An alternative is the hybrid processing. Allows for storing of part of the data and then part of it you would access. So just understand that these are two alternatives to OLAP. We won't go into those in any detail. Okay. So real-time data warehousing, remember I said before we would cover this again. Basically, data is provided as it becomes available, so it's real time. It's growing rapidly. More and more companies are needing it. It's just you have to make sure that you need it, and that if you're, say, doing a report, say for a meeting, if you pull information at 2:05, it's going to be different at 2:07. So there's always that concern of mismatch of information. And not all data should be updated continuously. Some data, it's going to be very arduous to update it constantly. It can be expensive, so it needs to be something really essential to the business if you need real time. And then depending on the business, it could be infeasible. Okay, so traditional versus active data warehouse environments. Traditionally, they were just strategic decisions. Active data warehouses are good for both strategic and tactical decisions. Maybe you need to make a decision quickly based on what your competitors are doing. Results are sometimes hard to measure. Results are measured with operations. So I said here, the big difference between traditional and active is how quickly information is available. So if you work for, say, a stock brokerage firm, you need up-to-date information on stocks, stock exchanges. You know, you see those tickers, they're constantly updating information. So that's the big difference. These are just some other little differences if you want to go over those. So that's a data warehouse. And one thing I wanted to cover, now you'll see that I have them separated by chapters. So week 2 and week 3. Is it week 3 and 4? Let's see. We'll open chapter 2. You'll see week 3 and week 4 are in chapter 2. All your assignments for the chapter are always going to be under the chapter link. So chapter assignments 2 and 3 will be here. But when I do to-do lists, like for week 4, I remind you when an assignment from the previous week is due. So keep up with that, and then I put a link to the previous page where your assignments are, so you can turn them in. Now this is a data warehousing tutorial. You read through this next week, the week 4. I'm not going to go over it because it's a very long slide, but it has a lot of good notes that you can read through. It's provided by Hugh Watson from Terry College of Business, University of Georgia. So it's just some developments in data warehousing. It's good to read through, but if you notice, it's 55 slides. So there's notes all the way through if you want to read through those. And that'll be your assignment for week 4. And then assignment 3 is going to be star schemas. Assignment 2, you're going to go back into the Teradata stuff again. So just make sure that I get the 2 Excel documents, the PDF document, and the Word document.